Hello, Atlas Camp. So I'm Tim Pettersen, engineering team lead on Forge.
And I'm Joël Kalmanowicz, Forge's principal product manager. Guten Tag und herzlich willkommen. Welcome back to Atlas Camp 2019. And thank you all for joining us here today. We're having a pretty good time. Are you all having a good time? Yeah? All right, nice. I won't make you do it again, I promise.
We're super excited to see so many familiar faces and a few new faces in the crowd as well.
Yeah, actually, we know many of you have traveled pretty far, and we truly appreciate you taking the time to be away from your work and your families to be with us here in Wien today. So let's make the most of our time and get the show on the road. As Mike called out yesterday, we are really still in the early days of developing Forge. If that big barge on the left is our vision, full of all the ideas we have, the little tugboat on the right is the work we've done so far that's pulling us forwards. And so we're sharing both of these with you here today in the spirit of open and agile, because we want your feedback so that we can iterate and build iteratively together to build value for you. With that in mind, let's start by zooming out to a little background on what got us thinking about Forge in the first place. We care deeply about users of Atlassian products, but also of everything our ecosystem builds. That's all of you. When you look at what these users need, a few big trends have emerged over the last few years. It starts with trust. As more and more personal information goes digital and into the cloud, privacy, transparency, and overall trust are more important than ever before, because software is always changing. New vulnerabilities are created frequently and discovered eventually, most of the time. And this doesn't just affect end users. Let's do a quick exercise to see how many of you have faced the effects of this already. Can I get you all to raise your hands with me for a moment? Everyone, come on. This is an opt-out. Bring your hands up. OK. Please keep your hand up if you have had to deal with GDPR in some form. When we did this exercise in rehearsal at Atlassian, it was pretty much the same. I tell you, we all care a lot about this. OK, you can put your hands down. Thank you. So, another engagement of trust, another thing coming out of all of this is the need for data residency. This is an increasingly common requirement for our customers, because this is growing along with the need for trust and a strong level of attention to privacy and security. That's why, as Nuwan said in his talk yesterday on preparing for data residency, we are working on giving admins the ability to control where their data is stored. Yet wherever the data is, Atlassian customers want experiences that are consistent across all their products and apps. And similarly, users want experiences that are consistent across their devices and the web.
But at the same time, as engineers, we want to care less about the platforms that we're targeting. We want to build against higher level abstractions that let us write less code and at the same time have more power in the apps that we build. And as developers, we don't want to care so much about whether our code is running on our local machine or deployed in a staging server or running in production. We just want to write it once. In software development, we sometimes refer to this as moving up the stack. We want to spend less time in the implementation details of the code that we're writing and more time focusing on delivering awesome customer value to the people who are using our apps.
And that's what Forge is all about. But before we jump into the details, let's talk a bit more about where we've come from so you can see why we believe that this will be a great asset to the ecosystem moving forward.
So cast your minds back to 2002 when Jira was born. There was no cloud, there was no server, there was only Jira. Now, in the early days of Atlassian, co-founders Mike and Scott were being swamped with feature requests from hot adopters of this great new issue tracking tool. So they took the unusual move to create a permissive source license for Jira, which means that you can legally fork Jira's code and start building your own features. Has anyone made their own customizations to the Jira source code and recompiled it and deployed it? Any hands? Oof, slightly scary number of hands. So this did have the desired result. Users could customize their Jira site to do whatever they wanted, and they built some weird and wonderful things. But this had the unexpected, or maybe expected, side effect of making Jira a little bit unstable. Those are not fireworks, by the way. Those are sparks flying off the server as an admin tries to upgrade to the latest point release of Jira Server. So in 2004, we invented Atlassian Plugins 1. Has anyone built a Plugins 1 plugin before? Any hands? OK, awesome. A slightly more comforting number. Back then, we thought, when we released Plugins 1, we abstracted away some of the logic of building a plugin with a healthy layer of XML and Java abstractions, which I'm sure many of you are working on today. So this was the mid-2000s. We thought we could solve all sorts of problems with XML, but it did show that there were still a few stability problems. Plugins still shared the same class path with Jira, which meant that your dependencies could conflict with each other, and also with Jira's core dependencies. And you also had to restart Jira every time you installed a new plugin, which was not a great user experience. So in 2008, we introduced Atlassian Plugins 2, based on OSGI. How many people here have built a server plugin targeting plugins 2? Awesome. OK, that's maybe 80% of the room. So this is awesome. OSGI allowed us to have dynamic plugin restarting and let us have proper API boundaries for the first time. Now, over time, as Jira matured, we refined our plugin architecture and extended it to some of our other products, like Confluence and Bitbucket Server. And we introduced a more or less stable API and started to build in abstractions and helper libraries that solved some of the common problems that our ecosystem was facing, things like Atlassian REST, or the shared application layer, and Atlassian objects for data storage. And of course, we introduced plugin licensing and the Atlassian Marketplace and paid via Atlassian add-ons. And these are sort of abstractions in the business sense. As Vitaly from Lizard Brain said yesterday in the keynote, Marketplace simplified the business aspects of planning poker so that he could go and concentrate on making the user experience better for his customers. So a simple contract started to emerge. Atlassian provides the platform, and our ecosystem, all of you, provide the kick-ass user experiences that provide business value to our customers. And for the most part, this has been a simple, powerful model that has stood the test of time. Apps built by people in this room are deployed on tens of thousands of customer sites around the world. But things are a little bit different in cloud. In cloud, your app is no longer a plugin that sits inside a JVM. It's an entirely independent web application that has to fend for itself. It just happens to know how to speak Atlassian Connect. Now, while in server you could lean on things like Atlassian REST and SAL to solve problems with storage and communications and authentication, in cloud you're responsible for building and hosting and operating an entirely independent web service. So as an Atlassian Connect developer, this means you need to be competent in cloud architecture and operations, which is quite a different problem space to traditional P2 development. Now, this is not a unique problem to Atlassian's ecosystem. If you're building an app for Facebook or for Slack or for many other cloud SaaS vendors, you're basically building against cloud APIs and webhooks. And in 2019, if you're dealing with cloud REST APIs and webhooks, then that means that you're dealing with user-generated content and potentially personal data and personally identifying information. And if you're dealing with some of these special types of data, then and you're building for enterprise customers, or you're building for companies that work in a certain industry, like healthcare or banking, or if you're simply building for enterprises with customers in a certain region, such as the European Union, then that means that your code has to be compliant with a number of different complex regulations, such as GDPR or SOC 2. So fortunately at Atlassian, we're actively planning for cloud apps of the future, with GDPR controls and data residency programs, and programs to enhance customer trust in you, our vendors. But there is a limit to how much we can abstract away the difficulty of dealing with some of these regulations in a system like Atlassian Connect. At Atlassian, we have 6 cloud data centers, and we have heaps of customers all over the world. But Atlassian's scale is a bit of a double-edged sword when it comes to the people in this room. There is a huge opportunity for every marketplace vendor to extend their offerings to our cloud customers, but there is significant complexity in extending those offerings to Atlassian scale in the cloud. So we started thinking, what if Atlassian could actually shoulder more of this burden for you? What if we could share some of Atlassian's infrastructure directly with our ecosystem? And so we assembled a team, and we started to build Forge.
We're introducing a new hosted app model with Atlassian-provided compute and storage. For compute, we're going with a FaaS, or Functions as a Service model. based on AWS Lambda. We're also creating a declarative UI language called Forge UI to help you quickly and easily build UI elements that look good across platforms. And we'll leverage some of Atlassian's unique assets and a few extra features to provide an amazing experience for all of you to use these new capabilities easily. Now, just to set some expectations, this is brand spanking new. We turned on Forge for a small set of Atlassians just last week. And we're a long way away from marketplace support. For now, we're iterating with a focus on developers who build custom in-house customizations for Atlassian tools and products that they and their teams use in their own organizations every day. So in the meantime, we encourage all of you to keep building for Atlassian Cloud using Connect. Forge is designed to be supplementary to the existing integration patterns that we support in Atlassian Connect. So things like iframes, webhooks, and remote API calls aren't going anywhere. And while marketplace support is a while away, we do want your feedback as soon as possible. As Atlas Camp attendees, you'll be right at the front of the queue for the Forge beta, which we're planning on launching later this year. You can sign up by scanning a QR code at the Forge booth or the labs. I've seen a bunch of you already doing it yesterday. If you haven't yet, now's your chance. But just in case later this year sounds a little bit like vaporware, please remember, you can get an early preview of Forge today and write an app on it. We have a special Forge Labs section upstairs in Schubert 3. Actually, can I just get a quick show of hands? How many of you have already checked out the labs yesterday? Wow, that's amazing. Thanks. Awesome. So you've opened up spots today for everyone else who hasn't tried it. All right, so please do go check it out. Now that we've set some expectations, let's talk about Atlassian hosting and why we think that functions as a service hosting models are the right fit for the Atlassian cloud ecosystem.
Awesome. Now, just to get a bit of an understanding of context, how many of you have used a functions as a service platform or a serverless platform before? So maybe AWS Lambda or Google Cloud Functions? Oh, OK, brilliant. That's maybe a quarter of the room. OK, excellent. Well, I think we'll go on a little bit of a journey and maybe talk about why FAS, how FAS came to be and why we think it is a good fit for the Atlassian ecosystem going forward. Because there's a few cool things that you can do with serverless in an ecosystem context that make it even better than some other problem domains you can use it for. So this time, we're going to go even further back than the birth of Jira, back to the early 1990s and the beginning days of the web, to a period known as the Metal Age.
We had to.
So in the 90s, if you wanted to build a web application, you were deploying on bare metal servers. That meant you had to go out and buy a physical server, plug it into the wall, then you had to install an operating system, install Java or PHP or, I don't know, write a web application in CGI bin. It was the 90s. And then once you'd deployed those things, you actually had to write some application logic to deal with this newfangled hypertext transfer protocol. And then once you built all that, you could actually start writing some business logic to solve your customers' problems. So this worked OK. But then if you wanted to build another app or scale your existing app, you had to buy another physical server, plug it in, install an operating system, and copy over your code and tweak it to deal with this new existential crisis of coping with a multi-host world.
And that changed in the early 2000s, when hypervisor technology was commoditized by companies like VMware. Virtualization meant that one physical server could actually be divided into multiple virtual machines. Practically speaking, this meant that you could buy one server and have different isolated environments for your apps to run in. You did still need to buy new hardware every now and then, especially if you needed to scale your applications.
Now, this changed in 2006 with the birth of infrastructure as a service. An enterprising young company, Amazon, launched EC2, the Elastic Compute Cloud. Now, this is basically just virtualization, but they built a business model of running all of the physical hardware for you and then renting you virtual machines by the hour. So that meant that developers were completely abstracted away from the details of running those physical servers and provisioning new virtual machines themselves.
And in 2009, Heroku launched a new spin on infrastructure as a service known as Platform as a Service, or PaaS. A PaaS provider manages the operating system and runtime for you, abstracting away even more complexity. So instead of managing your own system configuration, you simply uploaded a Ruby on Rails or Java WAR file or another application bundle along with some deployment config, and it handled everything for you.
So internally at Atlassian, we actually have a PaaS that we use to deploy all sorts of Atlassian applications and services called Micros. Now, this PaaS used to support a bunch of different application runtimes, Java, Node.js, but we've deprecated all of them except for one. And that is a new technology, well, was a new technology in 2013, which was a new way of deploying applications that caught on like wildfire. Docker containers gave developers a mechanism to package their applications so they could run locally and in production with minimal changes to the configuration, and both without having to worry about the underlying infrastructure at all. So since then, containers have turned out to be pretty awesome. Orchestration tools like Docker Swarm and Kubernetes have made it possible to build applications out of lots and lots of containers working in unison. And cloud hosting providers like AWS have launched managed container-as-a-service platforms, so you can spin them up and spin them down extremely quickly and easily.
But in 2014, just as Docker was exploding in popularity, Amazon launched AWS Lambda, which is sort of like taking PaaS to an extreme. Using lightweight virtual machines and a specialized application layer, Amazon abstracted away all of the runtime and application concerns down to a point where the developer can deploy a single function written in the language of their choice. And Amazon could then scale this function up to thousands of concurrent invocations and back down to 0 without the developer needing to worry about it at all.
Which brings us to today. Container-based systems give you a lot of flexibility in how you build your applications, but they also give you slightly more of the stack that you have to reason about when you're writing your code. Lambdas and functions give you a little bit less flexibility, but they do make the number of lines of code you actually have to write to get your work done much lower, like orders of magnitude lower, as you'll see in a second. When considering Atlassian hosting, we actually did first evaluate a container-based model where we provide an external-facing PaaS for ecosystem developers to run workloads in the Atlassian cloud. But we ultimately decided that a functions-as-a-service model built on top of AWS Lambda was the best solution to meet the needs of our ecosystem today.
So here are a few big reasons why we went with functions as a service. Less boilerplate is important because we're not here for the technology, even if it's pretty cool. We're not building Atlassian server plugins because we love OSGI. And we're not building on Atlassian Connect because we love iframes. We're here to deliver delightful user experiences. And the less undifferentiated boilerplate code we have to write, the better. And it's tenant aware. So this means when we invoke a Forge function, we can actually tie that invocation back to a specific customer site. And this allows us to automatically deploy your functions to the regions your customers are in, sandbox your code so you don't accidentally leak data across tenants, and pass those guarantees on to your users so they have automatic assurances when using your app. And third, tailored Atlassian abstractions, because with FAS, the edges of the platform are so much closer to your code, so we can inject helpers directly into the code to simplify working with Atlassian product APIs, and using our awareness of tenancy to automatically manage secrets and authentication for you.
And the most important requirement for me is that this allows ecosystem developers to move up the stack and spend more of your time building awesome experiences for our mutual customers. Now, as we already mentioned, there are a few features specific to a FAS compute model that help us achieve this. Functions are event-driven, kind of like plugins too. And with the power of AWS Lambda, they're scalable instantaneously and for most practical ecosystem purposes, near infinitely. But the best way to describe functions to a room that has a lot of engineers in it is to actually show it to you. So let's take Forge for a spin. Now we're going to build a very simple app using a Forge capability known as a product trigger. So this is the Forge equivalent of a plugins to event listener or an Atlassian Connect webhook. Basically, it allows you to listen to user-generated events that occur in Atlassian cloud products. Now specifically, we're going to listen to an issue transition event. And when that unissue transition event occurs, it's going to invoke a Forge function running on our Forge FAS platform, and then it's going to add a comment to the issue saying, hello, Vienna. So let's jump into the Forge CLI. So this is a command line tool for creating and managing your Forge apps. So first we'll enter a name for our app, and then we're going to select the blank starter template so we can demonstrate building an app from scratch. So this creates an app directory on our local disk and also registers our app on the Forge platform. Now at this point, our app is looking pretty empty. We have 2 files, a Bitbucket pipelines configuration file that we'll come back to a little later in the presentation, and we also have a manifest. So let's jump into an IDE and actually write some code. So this is Visual Studio Code, a pretty awesome IDE for writing JavaScript, which is the first language that's supported in the Forge runtime. So this is the app manifest, which is kind of the Forge equivalent of an Atlassian plugin XML file or an Atlassian Connect.json descriptor. Now, to listen to issue transition events, we're going to create a trigger module, which is, as I said before, is kind of like a webhook listener or a event listener from plugins too. So here we're just going to enter the name of the event that we're listening to. And then we're going to bind this trigger to a Forge function. We'll call it onIssueTransitions, sort of consistent with how I name event listener methods in P2 as well. Now here we're going to register a function as well. And this is going to be a pointer to the code that gets packaged up with our app, and also a pointer to an individual function that sits inside of that file. So now our manifest is complete. This is a working manifest. We just need to actually write some JavaScript. So let's create a new file and name it index.js to be consistent with the handler that we defined in the manifest. And we'll create that function name on issue transitioned. And we're going to make this an async function because we're going to be doing some asynchronous stuff, namely invoking the Jira API. Now, a function gets passed 2 arguments, an event object, which contains a little bit of information about the event that occurred, so an issue transition, and then a context object, which we're not going to be using right now, but this gives us a bit more information about the tenant in which the transition occurred. So our first line of code, we're going to pluck out the issue ID from that event payload so that we can pass it to the Jira REST API when we post that comment object. Now, the format for this event object maybe looks a little bit strange, but that's because we've standardized the event payloads across all of the different event types that we support and also across all of the products that Forge supports to make it a bit easier to reason about. Now we're going to create our comment, hello Vienna. And then for our third and final line of code, we're going to call the Atlassian Jira REST API. Now to do this, we're going to use this special API helper method. Now this is a global variable that gets injected into the function runtime, function context rather, by our runtime. And it has a bunch of different handy utility methods that abstract away some of the more traditionally painful bits of working with Atlassian APIs. Now what as_app is going to do is it's going to authenticate the request we make as the app's bot user. Now, as Joël said, Forge is still a bit of a work in progress, so we haven't actually built bot users yet. So instead, it's going to authenticate as me, the owner of the app. And then we're using this request Jira helper to make a request specifically to the product tenant that invoked this function. Now, you'll notice here we're passing a relative URL rather than an absolute one because this function is actually bound to that context. It can only make requests to this particular host, which is a pretty important part of the Forge security story and one of the important mechanisms we have in place to prevent accidentally leaking data across contexts. Now, the other thing you'll notice here is that we're not applying any authorization headers, and we're not applying a content type header because the API realizes that we're talking to Jira, which speaks JSON. So this is kind of neat because it means we're not actually exposed to user access tokens or secrets, so it means we don't have to reason about storing those or managing those, which is kind of handy for a lot of the regulations that are required of cloud apps these days. So now let's jump over back to our command line and actually deploy this app. So the deploy command packages up our app and then deploys it to the Forge infrastructure. So it's combining our manifest and JavaScript file into a single archive. And now we're going to install it. Now, eventually, this will be handled via Marketplace, but for now, we're managing it via the CLI instead. So now our app is installed, we should be able to actually jump over to our Jira Cloud site and test it out. So let's transition an issue to in progress, give it just a couple of seconds for good luck, and hey, we have a comment. Woo. So I mentioned one of the cool things about FAS is that it's really easy to scale. Now, we didn't write any specific scaling logic in our manifest or our JavaScript, but let's test that out. What's going to happen if we transition 50 issues at once? So we'll jump over to the issue navigator, and we'll hit the bulk change button. We'll select all 50 exciting user stories from the Forge backlog. Hit the transition issues radio button. And let's call them all done for now. And don't actually need to update any fields as part of this transition. So we'll confirm that we really want to do this. And now just give it a second or so while Jira updates those issues. And now if we go back to our issue navigator, and just maybe give it a couple of seconds, and then click on the latest issue from our backlog. Hey, we have a comment. Oh, actually, 11 seconds. Didn't have to wait that long. So what happened under the hood there is Lambda and Forge spun up 50 instances of our function and transitioned those 50 issues more or less instantaneously. So the automatic scaling is exciting, but the thing that I really like about this example is that we have a functional app, taking on a pretty trivial task, yes, but written in 3 lines of JavaScript and a handful of lines of YAML. So I think we're doing a pretty good job of abstracting away a lot of those common problems like authentication and tenant lifecycle and installations to make it super trivial to build apps.
So we just saw an example of a product trigger listening for issue transition events and adding some comments to a Jira issue. Now, this is actually a general purpose mechanism for listening to all sorts of events using any REST API supported in Jira Cloud. And what we haven't mentioned yet is that product triggers are cross-product by default. So today we support 26 events across both Jira and Confluence Cloud, and we have a standard event format. So if you're interested in just comment events, for example, you can build and deploy a single Forge function that lets you listen for comment events across both Jira and Confluence.
Because long term, we want you to be able to consume events from and make API calls to every product in the Atlassian cloud as we extend Forge support to them. Unlike Atlassian Connect, Forge has been built as a service-first approach, so we're hoping that it'll be reasonably straightforward to integrate the rest of the Atlassian cloud product suite in the near future. So product triggers allow you to consume Atlassian events, but a lot of integration apps and other workflow productivity apps have to integrate with third-party systems as well. So Forge has another mechanism called a web trigger that allows you to expose a Forge function to the public internet so you can consume webhooks and other types of requests from third-party services and tools. Now, just like product triggers, web triggers can automatically authenticate with the host products that they're installed into. And web triggers are basically a general-purpose mechanism that lets you consume anything capable of making an HTTP request. So this is great for webhooks, but you can also use it to power command line tools or build scripts or anything else that can make a request. And we've also introduced a very special type of function capability, which some of you might have played with in the labs yesterday, called an editor macro. So many of you are probably familiar with macros in Confluence Server and Confluence Cloud, but in Forge, we've taken the concept of an editor macro a step further. So a Forge editor macro springs to life when it is inserted into a page or viewed by a user. But instead of returning some rendered HTML or an iframe, it returns a new special markup format called Forge UI.
And Forge UI is a declarative UI framework that makes it easy to quickly build native, flexible, and trusted UI elements as part of your Forge apps. It consists of a component-based markup language for describing your app's user interface and a mechanism for managing state and binding UI controls to your Forge function. Like the rest of Forge, our primary motivator here is to help you move up the stack in app development. By trading off some flexibility, oh, sorry, got a little quick.
Sorry, mate.
That's all right. We're very excited about this. You can go back.
Yeah, sure thing. Cheers.
We gain a lot of convenience with some powerful abstractions that let you build delightful user experiences in just a few keystrokes. And building on our infrastructure as well means that your app's user experience improves with our products. So your app will always be running the latest version of Atlas Kit that's supported by the host Atlassian product. And when we update, your app won't break. All right, so getting back on track for us.
I'm just going to give this to you, actually.
By preventing third-party JavaScript from running in the application front end, we can also make guarantees to your customers about how user-generated content is handled and personal data as well for your apps. So it's secure. And you can find out more about how we've done this in Dougal's and my talk later today, called Trusted by Default. And finally, a declarative approach allows us to transform Forge UI markup into not just web application components, but also it lets us provide ecosystem experiences in Atlassian's native mobile apps. Let's take a look at some of these components. We've built an initial set of Atlas Kit-based Forge UI components and focused on the in-house developer use case to start with. Now, these will expand over time based on feedback and research. But we've already seen some pretty creative uses of even this initial set. And if you'd like to see what Atlassians have already built so far, check out Tim's Forge app showcase later today. So, where can you put these components? We're starting with editor macros, as Tim said. So anywhere you have Atlassian's rich text editor, you can use Forge UI. And as we bring the editor from Confluence into more products like Jira, Forge comes with it. Of course, we do have bigger plans than that. With Forge, our eventual goal is to help you build across Atlassian's cloud. So we want to bring Forge UI into popular extension points that we already have, like web panels, issue glances, and dialogues. And we're looking further to the future as well, exploring what else we can do with this. So we would love to hear your thoughts. In the meantime, let's come back to the present and see what can we do today.
So to show off some of the capabilities of Forge UI, let's take a look under the hood of a Forge-powered editor macro. Now, this is a super simple version of an app, so more just to kind of illustrate some of the concepts we're going after. Pete Gleason has a great talk at 10 o'clock this morning where he's going to go into much more detail about the capabilities of Forge UI and the developer experience as well. So I highly recommend checking that out. But in the meantime, let's take a little look at an app that's kind of like a simple version of the Jira Issues macro. So I'm going to build a to-do list that's going to call out to the Jira Cloud product attached to this particular site. And then it's going to fetch open Jira issues that are assigned to the current user and display them in a table. So what's happening here is that when our user views a Confluence page containing our macro, our function is invoked and passes some information about the page and the user viewing the page. It then makes an authenticated request to Jira, and then queries for open issues using Jira query language. Forge functions have another nice little helper API that we'll be demonstrating in just a sec. And then finally, it renders those issues into a table using some Forge UI markup. And then it returns it to Confluence to display. So let's take a quick look at some Forge UI syntax. So Forge UI is rendered using JSX, which is a markup language that resembles HTML to some extent and can be easily embedded in JavaScript. Has anyone here done some React development in the past? Or maybe worked with Atlas Kit? OK, fantastic. It's like maybe 20% of the room. So you'll be familiar with JSX if you have done React or Atlas Kit, but it is reasonably straightforward to learn if you haven't. So a Forge UI component can be as simple as a block of text, or in the case of our to-do list macro, we're going to need a table, which is constructed out of Forge UI components in a similar manner to an HTML table. First, we define a table and head section, and then a couple of cells to contain our column headers. So now we need to bind some data to our table. So let's assume for now that we have an array called issues that contains a set of issues that we've retrieved from Jira. So we'll map this list to a collection of rows using normal JavaScript syntax embedded inside of our JSX, or Forge UI. Now each row contains a cell with a nested text element containing the actual data from that issue, which gets displayed as part of the table. So we call Forge UI declarative because you declare your layout and data, and then we handle rendering it into the appropriate Atlas Kit components for you. So this is a really simple example, but from the slide Joël showed earlier, we do support rich UIs with text and buttons and drop-down menus and all sorts of other powerful components. And we're going to be expanding on those in the future. We've left off a slightly, well, actually not slightly, a very important detail as part of this example. How is that issues variable actually being populated from Jira? So if we look at the code, a little bit higher up in the macros implementation, there's some JavaScript that's executing a JQL query against Jira. So first we construct a query that will get all of the open issues for the current user. And then just like in our previous example, we're going to make a request to the Jira REST API using the request Jira helper. Now, the REST API call is a little bit different in this example. Instead of authenticating as our app's bot user, we want to impersonate the user viewing the page. So we use the as user helper instead of as app. Now, the as user helper changes the user experience of the app quite significantly. Instead of just immediately seeing a list of issues, which I would see as the app's owner because it has the automatic ability to impersonate me, if another user, say in this case Mia Olinik, accesses the page, then she'll first see a prompt to consent to allow the app to access data in her account. Now, if we click on the Allow Access button, we get sent through what looks very much like a standard 3LO flow. Once we accept our beautiful new European Union compliant cookie policy and select the site which we're granting consent for, then the app will have permission to actually make a request on behalf of Mia. So we're giving users back a little bit more of their ability to control where their data goes and how it's used. Now, under the hood, there's actually quite a lot going on here. There's an OAuth dance, there's authorization tokens and secrets being stored and used, and some interplay between Confluence and Forge and api.atlassian.com, which is hosting these APIs. But as a developer, you don't have to worry about any of that. It's all handled by that as user helper. One line of code, and you not only have have an app that respects the user's control of data, it also saves you from having to store user secrets and orchestrate fairly complex authentication protocols. Now, the other thing I want to point out here in this code is that we're using the request Jira helper from a macro that's installed in Confluence. That's because we requested permission from that user for an Atlassian domain rather than just a single product. So that means that you can easily create apps that work against an end user's entire Atlassian context rather than just a single product. We also have a similar request Confluence helper that you can use from apps installed in Jira. So this is great for all sorts of cross-product apps and use cases. Now, in the future, we want to extend this support to the full suite of Atlassian products, although, to be totally honest, we are a little way away from that at this point. So we've also spiked support for automatically authenticating with third-party services as well. So we've got this, we've spiked support for this, hasn't actually shipped to labs yet. But if you are working with an external service that also supports a fairly standard OAuth 2 flow, then you can use this special request external helper that will automatically manage that authorization dance that we saw and handle storing access tokens for each individual Atlassian cloud user. So this, again, saves you from having to muck around with storing user secrets, handling refresh flows, and dealing with users authenticating and then revoking access. All of that is abstracted away from you as well. Now, we're going to move on from the to-do list app now, but if you are interested in learning a little bit more about Forge UI and editor apps, please do check out Pete Gleason's talk that I mentioned before, starting at 10 o'clock. So Joël showed a few examples of components that are supported in Forge UI today. But I wanted to show you a couple of components that we're thinking about for the future that really demonstrate the value of a declarative UI and why we're investing in this area. The Atlassian editor is a really good example of this. Where we want to be is with, so at the moment, we have an editor macro that's embedded inside the Atlassian editor. But the Atlassian editor is potentially a pretty cool component for powering rich text fields in your own applications. Now, the editor is super powerful. It's what powers the page and blog experience inside of Confluence Cloud, and also rich text fields in Bitbucket and Jira. And it has a set of plugins that customize its behavior for the different types of places it's installed. What we want to do is have a rich content field where you can inject an editor into your own app's user experiences, and then we handle all of the wiring up so that it works properly for your users in the correct context. But a declarative model also allows us to play some other pretty powerful tricks. Here's a really simple card component that's displaying some information about a user. Now, there's two potential ways you could implement this using Forge UI. You could use a card component and wire up the image based on the user's avatar and use the content and subtitle properties to display their personal information. Or you could use a user card component and pass in the account ID, and we'll handle all of the rendering for you. Now, other than the fact that use a card is slightly more declarative and less code, there's a really important reason why you might want to pass an account ID to a card rather than that personal data. Can anyone guess why that might be? Did I hear that? GDPR? That's right. With Forge UI, we can abstract away GDPR. Woo! And if that isn't exciting enough, a declarative markup language also lets us abstract over different front-end platforms. A subset of Forge UI components will be supported in the official Atlassian mobile apps in the future and can be rendered using exactly the same Forge functions that you're building for the application experience in our web apps. So where we want to get to with our mobile support is for you to be able to think of an idea, build it targeting our web platform, and then not have to actually realize that our iOS and Android apps exist. It should just work out of the box without you having to reason about those different platform experiences. So this is why we're really excited about declarative UI.
So to recap, with all the benefits provided by a declarative UI language, we believe that Forge UI, despite being a little less flexible than iframe, will ultimately result in a better developer and user experience. And this should be true for most apps, because with powerful components and a baked-in security and privacy, it's both cross-platform and cross-product. We believe that you can spend less time writing undifferentiated boilerplate code and more time building awesome features. And remember, Forge UI is designed to complement iframes already supported in Atlassian Connect. So those of you building unique iframe-based experiences can continue to do so. Now, as we mentioned at the beginning, and just gave you a preview of, we've set our sights on the world's best developer ecosystem experience. Another reason we elected to go with a functions-as-a-service approach, as opposed to a platform as a service, is because we can exploit a unique attribute of the serverless compute model to power a fantastic DevOps experience and toolchain that will help you scale your app to support an Atlassian customer of any size. Let's talk about it. You may have noticed that Atlassian was slightly obsessed with the concept of teams. Many marketplace vendors and in-house developers are not building apps by themselves, but rather as part of a team, as I'm sure many of you here today are. Now, most modern software teams practicing DevOps have a staggered promotion flow for deployments. Code starts on your local machine and then is deployed to shared staging environment once it passes the tests, and then it's promoted either manually or automatically to production. Hopefully, this isn't news to anyone. The interesting thing is, as you get more confidence in stability and performance, that's when it gets close to production. We can do something with this.
So as we mentioned right back at the beginning of the presentation, in that sample template that we created, there was a file called bitbucketpipelines.yml. So this is some configuration for Atlassian's or Atlassian Bitbucket's continuous integration and deployment tool that is baked into Bitbucket called Bitbucket Pipelines. So when you create an app with Forge, we automatically generate some Bitbucket Pipelines configuration for you. Now, this is not prescriptive. You don't have to use Bitbucket Pipelines if you don't want to. You can use any CI/CD tool for deploying Forge applications. But if you do use pipelines, then when you push your Forge app to a Bitbucket repository, you instantly get a deployments dashboard with 3 separate environments. The environments that Joël just mentioned: development, staging, and production. Can I get a quick show of hands? How many of you have actually used Bitbucket Pipelines? Oh, OK, cool. Maybe 20% of the audience. That's exciting. For the rest of you, you're in for a treat. Now, Bitbucket Pipelines, actually, this doesn't really have anything to do with Forge, but you can use Bitbucket Pipelines today to have a really cool CI/CD process for Atlassian Plugins 2 plugins or Atlassian Connect apps. So I highly recommend checking it out. One of the really cool features that I love about pipelines is this little promote button that we have on the deployment dashboard. Now, that promote button has some magical powers that give me a sense of well-being when I consider doing what is traditionally a stressful thing, promoting code from one environment to another. If you press that button, it gives you a preview of all of the changes that are going to be promoted from one environment to another. Now, the first view that it shows you is a list of commits. This is pretty standard. Most CI/CD tools worth their salt have some sort of view like this. But where Bitbucket Pipelines really starts to shine is with its kick-ass Jira Cloud integration. Because if I click on this little Issues tab, I see a list of all of the issues that are about to be promoted from one environment to another, which is a much more logical view of the changes that are going to be promoted and the actual value that I'm going to be pushing into my next environment and onwards towards my customers. And we also have this diff view as well, which is a unified diff or patch of all of the changes that are going to be promoted. Now, usually I don't use the diff view because it can be quite verbose, but it is super useful if something goes wrong with the deployment and you need to come back and understand exactly what changed line by line. So these features, along with that big friendly green status, all give me the confidence that doing that promotion is going to result in a stable environment once I promote.
So Forge gives you 3 environments by default. But what about all these other people over here? The developers. As I said earlier, our team needs 3 permanent environments to practice proper DevOps. But we also need at least 1 sandbox environment for each developer to employ their own work in without stomping on each other's changes.
That is a really great point, Joël. In fact, I think we can go further. Because when we first spiked Forge, we gave each developer an individual sandbox environment to work with. But we quickly realized that developers sometimes need more than one version of their code running. What if Alana needed to check out and deploy a previous version of an app in order to be able to verify a bug report from a customer? Or what if Jose needed to quickly create an environment based on production in order to be able to perform a hotfix to get a critical production fix out as quickly as possible? Or what if Mia simply wanted to deploy the tip of a pull request so that her teammates could play around with her code in an exploratory testing environment whilst reviewing it? So we took a look at Forge and at our infrastructure and then decided, hey, why don't we just give Forge developers as many environments as they like? Now, in a platform as a service model, or if you're deploying bare infrastructure onto an infrastructure as a service platform, then provisioning unlimited environments is a crazy amount of resources, and it would be prohibitively expensive. However, in a functions as a service model, this is not only practical, it's actually dirt cheap. And this is because functions as a service platforms have one really cool feature. Well, a lot of really cool features, but one really cool feature for provisioning environments, and that is that they are extremely efficient when it comes to resource utilization. When a Forge function is not actively serving a user request, it doesn't exist. Now, this is great for pricing, but it's also great for other things like security. It's much harder for an attacker to breach a system and gain some persistence on something that doesn't exist for more than the lifespan of a request. So let me illustrate this using that simple product trigger example that added comments to issues when they're transitioned. When that transition event occurred, that instance of our Forge function didn't actually exist. What happened is Amazon quickly booted up a lightweight virtual machine, deployed our function code to it, and then tore it down again as soon as that, or suspended it rather, as soon as the function exited. So this is the magic that allows FAS to instantly scale up to support very large numbers of concurrent executions, and then scale back down to 0 very quickly to keep costs reasonable.
Bitbucket pipelines and FAS environments are just the beginning. We plan to continue leveraging the unique tools and assets that we have at Atlassian to make the best possible developer experience for our ecosystem. Because building a modern platform takes a lot of thought and time investment in infrastructure, system scaling, performance, monitoring, networking, auth, and hang on, let me get this one right, it's security. And done. Okay, well, almost done. Yeah. We want to do the heavy lifting for you to reduce the mountain of work on developers so you can just focus on getting things done and innovating on top. Because with our hosted FAS infrastructure, declarative UI, and amazing developer experience, we want to help you move up the stack. And it is a choice. If you want to dive in and build your own Connect app, or wire up Forge's logging to your own monitoring systems, you can. But with Forge, we would like to give you an easier alternative. Because our vision is to build a platform enabling any marketplace vendor, with a small team, even a team of 1, to just build an app and service Atlassian's largest customers. And remember, we have a full track of Forge goodness ready for you today to go into more detail on all of this. We're going to start with Pete Gleason, which we've referred to a few times, building an editor macro and walking through a lot more detail on that with Forge UI. Then Shoya is going to take you through the Forge runtime before Michael and Simon give you much more detail on the details of Forge UI and how you can customize Atlassian UX.
After lunch, Tomek from the Atlassian Platform Services team is going to give a much more comprehensive deep dive onto product triggers and web triggers and show you a really cool example of an Atlassian Jira Ops Genie integration that's built on top of it. After that, Jimmy, who's the feature lead on the Forge FAS platform, which is the underlying infrastructure that wraps your code and deploys it to Lambda, is going to talk a little bit more about that world-class developer experience that we're trying to achieve by showing off some of the observability and troubleshooting features baked into the Forge CLI and runtime. And then Joël and Dougald, our security champion on Forge, are going to have a great talk called Trusted by Default, where they're going to talk about some of our forward-looking thoughts about how we can have trust and privacy baked into the code that you build and run on Forge.
And then rounding out the afternoon, we're going to have Allard and Joe, who've been focused on Forge UI, walk you through a lot more of the history of how they came up with it and how they came up with the components that we're starting with. Then, check out Tim's Forge app showcase to see a few things that Atlassians have built using Forge UI.
Got some really cool stuff there.
Oh, yeah. And finally, Patrick, our architect, will walk you through a lot of the information around how we put everything together from the beginning. And don't forget, we do also have the labs all day where you can try it out for yourself. Finally, a big shout out for our team, because speaking of hands-on,
we've just locked in the dates and location for our first App Week of 2020. So it's going to be January 13th through January 17th in Scottsdale, Arizona. So we haven't picked an official theme yet, and App Weeks usually have a theme.
It'll probably be Forge.
We'll see. But please keep an eye on the Atlassian developer blog for details on how to apply. So we'd like to invite all of you to join us on this next step in the Atlassian cloud ecosystem journey. So please check out the Forge track in La Havre 4, which is the closest track room to us right now.
Or come talk to us at the booth near Stolz at the far end.
And please do try the hands-on Forge experience at Labs up in Schubert 3.
And sign up for the beta by scanning a QR code at any of those locations using the Atlassian Events app.
And above all else, based on all the content that you see in the sessions today and the keynote and your experience in the labs, please be as frank and forthcoming with feedback as you can. As Joel said earlier, this is a super new platform that we literally just turned on last week at Atlassian, so we're learning a lot. But we can't wait to build the next generation of the Atlassian cloud platform together.
Thank you.